Before we go any further, I need you to know something. Reality glitches, and not just in video games. There are real experiments where particles change their behavior depending on whether you're watching. And the craziest part, this quantum weirdness is happening inside your phone right now. Let's break down the secrets of the universe using everyday stuff you already understand. So, what even is quantum physics? Simply put, it's the rulebook for the smallest pieces of reality: electrons, photons, atoms, basically the pixels of our universe. When you zoom in far enough, the rules of normal life just completely break down. Things can be in multiple places at once. They can teleport information instantly. And they can act like both waves and particles, totally ignoring classical logic. It's like discovering your toaster has a secret, very strange nightlife you never knew about. First up is a concept called superposition, which basically means, yes, both at once. Superposition is the idea that a particle exists in multiple states at the exact same time. Think of it like this. You send someone a text, "Are you coming?" and they don't reply. Until they answer, they are basically both coming and not coming simultaneously. That's superposition. Electrons do this all the time with their spin, their position, their energy. They're just indecisive little rebels until you measure them. The moment you look, they finally pick a lane and decide on a single state. Now, let's talk about the double-slit experiment. This is the one that made physicists question their life choices. If you roll marbles through two slits in a board, you get two piles on the other side. Simple, right? But if you fire electrons through those same two slits, you get a wave pattern, as if each electron went through both slits at the same time. But here's the plot twist. If you put a detector there to watch which slit the electrons go through, the wave pattern disappears. The electrons suddenly start behaving like normal, boring particles again, making two neat piles. It's like your dog acting perfectly behaved only when you're looking directly at it. This is genuinely one of the biggest what just happened moments in all of science. Next, we have quantum entanglement, which I like to call the cosmic phone line. Entanglement is when two particles become linked so deeply that whatever you do to one instantly affects the other, even if they're on opposite sides of the galaxy. Imagine you have a pair of special socks. You keep one and your friend takes the other one to the moon. Until you look, both socks are in a weird mix of being both a left sock and a right sock. But the moment you check yours and see you have a left sock, bam, you instantly know your friend on the moon has the right one. Einstein called this spooky action at a distance, which, coming from Einstein, basically means, this makes no sense. Please send help. Then there's quantum tunneling, which is basically cheating through walls. Quantum tunneling is when a particle slips through a barrier it shouldn't have the energy to cross. Imagine you're driving up a really steep hill but you don't have enough gas or power. Logically, you should roll backwards. But in the quantum world, sometimes, you just pop out on the other side of the hill anyway. This isn't just a weird theory. It actually happens in your phone's electronics billions of times every single second. And without tunneling, the sun wouldn't even be able to shine. The universe literally depends on cheat codes to function. This brings us to the uncertainty principle, or what I call reality's built-in privacy mode. Heisenberg's uncertainty principle states that if you know exactly where a particle is, you can't know exactly how fast it's moving. And if you know its speed perfectly, you lose track of exactly where it is. Think of a spinning fan. When it's spinning super fast, the blades are blurred. You know the speed, but not the location of any single blade. When it stops, you can see the blades perfectly, but now they're not moving. Reality forces you to choose what you want to know. The universe has its own privacy settings. So how do we use all this weirdness? Enter quantum computing, the superposition power-up. Normal computers use bits, which are either a 0 or a 1. Quantum computers use qubits, which can be a 0, a 1, or both simultaneously, thanks to superposition. Imagine trying to find one specific key in a giant, messy bowl full of keys. A normal computer would have to check them one by one. A quantum computer, however, can check a whole bunch of them at the same time. That's why they're so powerful for things like breaking encryption, simulating complex chemistry, discovering new drugs, and boosting artificial intelligence. They're not magic, but they are a massive leap in computing power. Now, for a truly mind-bending idea, the many worlds theory. It's basically the multiverse, but scarier. One interpretation of quantum mechanics suggests that every time a quantum event happens with multiple possible outcomes, the universe actually branches off. So, in one universe, you had coffee this morning. In another, you spilled it all over yourself. In yet another, you didn't even click on this video. While it's not proven, the math behind it works. If it's true, it means that every single possibility happens somewhere. So, somewhere out there, there's a universe where you're a billionaire quantum physicist. And yes, they're probably watching a version of this video too. So, what's the takeaway from all this? Quantum physics sounds completely crazy because we don't see these effects in our everyday large-scale lives. But everything around you, your GPS, lasers, your smartphone or MRI machines, all of it exists because these bizarre quantum rules are real. The quantum world is deeply weird, but it's that very weirdness that builds the world we live in. Reality is far, far weirder than fiction. If you enjoyed this ride into the quantum realm, hit that like button, subscribe, and tell me in the comments which quantum WTF topic you want me to tackle next. Because here, we don't just explain reality, we break it open. Thanks for watching.